Hi, I am G. Dharma Teja, Assistant Professor working in a Mlritm college. Today we are going to discuss about a topic highway geometric design. In that we are going to discuss about a subtopic side distance. Okay, what do you mean by side distance? Side distance is available from a point is the actual distance along the road surface over which a driver from a specific height above the carriageway has visibility of a stationary or the moving object, okay, on the same lane. Okay, so what is the specific height? As per IRC we will be taking driver height as a 1.2 meters, okay, and object height, if you are taking about a object height, it is of 0.15 meter. Okay, so what are the side distance situations? Okay, these are the few side distance situations we are going to consider in the design process. So what are those? Stopping side distance, or we can call it as a absolute minimum side distance. Second is intermediate side distance. Third is overtaking side distance. Fourth is headlight side distance, and fifth is safe side distance at intersections. Okay, the safe side distance we are providing at the intersections. Okay, the most important considering in all the side distance situations. Okay, what are the five we are considered? The most important consideration is at all the times the driver traveling at the design speed of the highway must have sufficient carriageway distance, okay, within his line of vision to allow him to stop his vehicle before colliding with a slowly moving or a stationary objects appearing suddenly in his own traffic lane, okay, on which the driver is moving. Okay, that lane we are considering. Okay, if any slow moving or stationary object is there, so the driver has to visualize that object and he has to stop that vehicle, okay, in order to avoid collision. Okay, that is what the purpose of side distance. Okay, the computation of side distance. Okay, so what are the factors that side distance depends on? Okay, first is reaction time of the driver, speed of the vehicle, efficiency of brakes, okay, and frictional resistance between the tire and the road. And next is gradient of the road. Okay, first we are going to discuss about the reaction time of the driver. Reaction time of a driver is the time taken from the instant the object is visible to the driver to the instant when the brakes are applied. Okay, so that is the total reaction time. Okay, and the total reaction time has a four components in it as per the PIV theory. Okay, as per PIV theory, there are four components in it. Okay, what are those? First is perception, intellection, emotion, and volition. Okay, if you see the figure, it is easily understandable. Okay, so what we are doing, the driver is visualizing the object on the own traffic lane. Okay, so that is perceiving the information. So what is happening after perceiving the signal is transmitted to the brain. Okay, so intellection. Okay, so there is a process going on, okay, based on the visual what you are seeing. Okay, and there is emotion. Okay, so what we have to do, that is a emotion, okay, based on the visualization what we are seeing. So what is the emotion that he has occurred on the brain? Okay, so next is action. Okay, action is nothing but response. Okay, that is volition. Okay, in practice all these times are usually combined into a total perception reaction time. Okay, suitable for the design purposes as well as for the easy measurement. And IRC suggests the total perception reaction time as 2.5 seconds, which is very important. And next parameter is speed of the vehicle. Okay, the side distance depends on the speed of the vehicle. The speed of the vehicle very much affects the side distance. Higher the speed, if you are taking higher the speed, more time will be required to stop the vehicle. Okay, so the our motto is to stop the vehicle, okay, whenever we see the object, okay, on the own traffic lane. So higher the speed, that means the more time will be required to stop that vehicle. Okay, hence it is evident that as the speed increases, side distance also increases. Okay, we will be seeing the formula also, from the formula which is a derived one. Okay, but we will see the final formula. Okay. And next is efficiency of brakes. The efficiency of the brakes depends upon the age of the vehicle characteristics, tire characteristics, etc. Okay. If the brake efficiency is 100%, what do you mean by brake efficiency is 100%? The vehicle will stop at the moment when the brakes are applied. Okay, where if you are applying the brakes, then the vehicle will stop immediately. Okay, if the brake efficiency is 100%. Okay, but practically it is not possible to achieve the 100% brake efficiency. Therefore, the side distance required will be more when the efficiency of brakes are less. Okay, so the side distance will be required will be more. Okay, when the efficiency of brakes is less. Also, when we are considering about safe geometric design, okay, when we are designing, what we'll assume, we will assume that the vehicles have only 50% brake efficiency. Okay, that is the assumption we are making. Okay, while we are designing. Okay, while we are going for the safe geometric design. And next is frictional resistance between the tire and the road. Okay, the frictional resistance between the tire and the road plays an important role to bring the vehicle to stop. Okay, whenever we are applying the brake, okay, if there is no friction, the vehicle won't stop, right? So that friction between the tire and the road is the most important one in order to stop the vehicle. Okay, when the frictional resistance is more, okay, if the friction is more, the vehicle stop immediately. Okay, thus side distance required will be less. No separate provision for brake efficiency is provided while computing the side distance. This is taken into account along with the factor of longitudinal friction. Okay, IRC has specified the value of longitudinal friction is between 0.35 to 0.4. Okay, which is the other important one after the perception reaction time. Okay, this is a longitudinal friction, right? There is also a lateral friction. Okay, and next is gradient of the road. Okay, gradient of the road affects the side distance while climbing up the gradient. Okay, while we are traveling on the upward gradient, the vehicle can stop immediately. Okay, therefore side distance required might be less. Okay, but while we are descending the gradient, okay, while we are moving on the downward gradient, what will happen, there is also a gravity, the weight of the vehicle also comes into the picture. Okay, so the time required will be more, okay, for stopping the vehicle. So side distance required will be more in the case of the descending gradient. Okay, so we are taking the situations. What are the situations that are considering in the geometric design? Okay, first situation is stopping side distance. So what do you mean by stopping side distance? It is the absolute minimum side distance available on a highway at any spot having a sufficient length to enable the driver to stop a vehicle traveling at a designed speed safely without collision with any other obstruction. Okay, the stopping side distance is the basically sum of the lag distance and the braking distance. Okay, so what I mean by lag distance is the distance the vehicle traveled during the reaction time. We discussed about the total reaction time, right? So that is the distance that vehicle travels during the reaction time. Okay, and next is braking distance. Braking distance is when we use occurring after the application of brakes. What is the distance that vehicle travels? That is a braking distance. Okay, is the distance traveled by the vehicle during braking operation. Okay, for a level road, this is obtained by equation the work done in the stopping of the vehicle and the kinetic energy of the vehicle. Okay, so from the figure, if you observe if the vehicle, okay, the driver on the vehicle here perceives the object. Okay, so what is happening, there is a reaction time going on. Okay, there is a, according to PAV theory, as we discussed, there are four components: perception, react, intellection, emotion, and violation. So that is the total reaction time. Okay, at that total reaction time, we will be having a that vehicle that covers the distance is called as a lag distance, and after applying the brake, we having a braking distance. Okay, so the stopping side distance is a summation of both lag distance and the stopping side distance. Okay, so even if you observe in the formula, lag distance and braking distance, okay, VT is a reaction time distance, that is a lag distance, and V square by 2G. Eta okay, is a brake efficiency, F is a coefficient of friction, and N is a gradient. Okay, so this is a braking distance. Okay, this is a lag distance and this is a braking distance. Okay, so the velocity here we will be taking in the units of meter per second, whereas T will be taking in the seconds. Okay, and is we discussed about the gradient. Okay, if positive sign is a, we will be taking it for the ascending gradient, that is upward gradient. Negative sign for the descending gradients. Okay, and eta is a braking efficiency, F is the coefficient of friction. Okay, next situation we are going to talk about is overtaking side distance. Okay, or we can call it as a passing side distance. Okay, the overtaking side distance is the minimum distance open to the vision of the driver of a vehicle intending to overtake the slow vehicle ahead safely against the traffic in the opposite direction. Okay, the overtaking side distance or passing side distance is measured along the center line of the road. Okay, over which a driver with his eye level of 1.2 meters above the road surface can see the top of an object 1.2 meters above the road surface. Okay, that is the consideration we are taking place while we are doing overtaking operation. Okay, so while we are doing overtake operation, if there is opposite vehicle, okay, on the other lane, okay, not on our own traffic lane, other lane, so we will be taking these considerations. Okay, so what are the factors that is affecting the overtaking side distance? One is velocities of the overtaking vehicle. Okay, velocity of overtaken vehicle and the vehicle coming on the opposite direction. Okay, and the velocity of the vehicle that is coming on the opposite direction, that is on the other lane. Okay, spacing between vehicles, which in turn depends on the speed. Okay, spacing between vehicles is nothing but we can consider it as a headway. Okay, which in turn depends on the speed of the vehicle. It is indirectly dependent on the speed of the vehicle. Next is skill and reaction time of the driver, which is very important. Reaction times comes here also, and rate of acceleration of overtaking of vehicle. Okay, next is gradient of the road. Okay, these are all the factors that will be influencing the overtaking side distance. Okay, and next is intermediate side distance. Intermediate side distance is defined as twice the stopping side distance. Okay, it is a direct formula. Okay, but how it is defined? The intermediate side distance will be used when the overtaking side distance, okay, cannot be provided at that particular location. Okay, especially while we are in the constrained conditions, that is at the hilly conditions. Okay, and cost limitation conditions, we will be providing intermediate side distance. Okay, and the intermediate side distance will be mostly used on the two lane roads. Okay, and next is side distance at the intersections. Okay, at intersections when two or more roads meet, that is what do you mean by intersection, right? There will be two or more roads will be meeting. Okay, visibility should be provided for the drivers approaching the intersection from either sides. They should be able to perceive a hazard and stop the vehicle if required. Okay, stopping side distance for each road can be computed from the design speed of that particular road. The side distance should be provided such that the drivers on either side should be able to see the each other. Okay, that is the motto. Okay, design of side distance at intersections may be used on three possible conditions. Okay, so we will be considering these three conditions, okay, while designing the side distance at a intersection. Okay, first is the first one, it will be enabling approaching vehicle to change the speed. Okay, we will be decreasing, or we will be mostly decreasing the speed of the approaching vehicle. Okay, and next is approaching vehicle to stop. Okay, either we will be stopping the approaching vehicle. Okay, and next is enabling stopped vehicle. If there is any stopped vehicle, we will try to cross that the main road. Okay, so these are the three conditions which will be used for design of side distance at intersections. Okay, and next is headlight side distance. Okay, headlight side distance mostly we will be using it in the summit curves or crest curves. Okay, it is the distance visible to a driver at night under the illumination of vehicle headlights. Okay, so at the night time, as the vehicle moves, there should be sufficient sight distance, okay, in order to see the opposite vehicle. So what will be happening? So there will be a very the light will be, the visibility will be very low at the night time, right? So under the illumination of vehicle headlights, you have to perceive that vehicle. Okay, so that is the distance. So it depends mainly on the height of the headlight, which will be usually 0.75 meters from the ground surface. Okay, and next is beam angle. Okay, this is also mostly will be taking 1 degree in upward direction. Okay, so these two are the main factors that headlight sight distance depends on. Okay, so what is the condition of safety? We will be talking about headlight sight distance should be greater than equal to stopping sight distance, right? It will be very important on the crash course, as we discussed. Ensures drivers can see and stop within the illuminated area, right? And these are the some of the references. Thank you.